Hey guys, today we'll be going over how to create a networking layer in an iOS application. Typically in an iOS application, the application needs to make an API call to a server in order to retrieve some data or information and display that in the app. So today we'll go over how to create that networking layer using Alamofire and PromiseKit. I think creating it this way is pretty convenient and it's pretty easy to use, so we'll go over a few examples and let's see how that works. Okay, let's get started. Alright, so we'll get started by creating an iOS application. Open up Xcode, create a new app. We'll just call it networking template, and we'll be using Swift lifecycle storyboard. Okay, let's go next. Okay, create it on desktop, so we'll create our project and click create. A little bit slow here. Alright, so we have our application with some default files. So first thing we're gonna need to add is Alamofire and PromiseKit, and we'll be adding that with the Swift package manager. So go to your project here, go to the Swift packages tab, and then we need to add the Alamofire and PromiseKit packages. So go to Google, just search for Alamofire GitHub. Once you go there, you can click into it and then copy the link in the bar. Copy, go to here, paste it, and click next, and then alright, so it retrieved the repository for us for Alamofire. Click next. Install Alamofire. Okay, check out. So with me. Okay. Then we click finish, and it added Alamofire to our Swift package dependencies. And we're gonna do the same thing for PromiseKit. Go to Google and then search for PromiseKit GitHub, and just click on the first link. Again, from the address bar, just copy and add another package to your Swift package repository. Paste it here. Click next. All right, go next. So with it. So in the meantime, as it's doing this, I'll just finish. Still waiting. There it is. PromiseKit, then click finish. Okay, so now we have our packages that we need, Alamofire and PromiseKit. So now that we have it ready, we'll just quickly look for some sites that can provide us some API, like some free JSON API testing. So we'll search for JSON free API for testing. So that way we don't have to set up a server or anything. We'll just make some calls in order to get some JSON responses. So here, just go to the first link, JSON placeholder dot typey code, and then okay, so here's this call. Let's run script. Okay, so we have a little model that it spits out. So when I make this call, it gives you the response here. So let me open up Postman and verify that it does that. So Postman is an application that uses to make some network calls and see responses. So one second, we'll Postman here. Postman. Alright. Actually, that's good. I've done that before. Alright, so we pasted the call that we were going to make, and then so this is our response that we get. So that's all good. We find our we found our API that we're gonna be trying to hit and retrieve this data and using this data in our application. Okay, so first thing we're gonna need to do is we can create a new group specifically for to separate out the networking. So we'll create a new folder or new group, and we're just gonna call this networking. And so in our networking, we're gonna have our networking, we're gonna have our API router. 1 second. New file. It's gonna be a Swift file. Computer's really slow. API router. Let's create that here. All right. So in our API router, we'll be using Alamofire. All right. So we have that, and then we'll just begin setting up our API router. Enum API. Just call this one API router. So in our API router, we'll have the endpoints. So for this one, let me copy this onto a new tab. Just kind of see. All right. In our case, so we'll have different cases for the different endpoints that we're gonna have. So this one, let's call it to-dos. Case to-dos. So in case to-dos, and then we're gonna have variables for each of the cases. So the to-dos is an endpoint. So variable, we're gonna have a variable called base URL, which is what happened? All right, which is gonna be a string. Make this a little bit bigger. Alright, it's gonna be a string, and then we're gonna do switch self, and case to do's. Our base URL would be this is our whole base URL plus endpoint. So our base URL is going to only go up to the .com part. The rest of it would be considered the path. So in case to do, that's our base URL. So basically we're gonna define a bunch of things that's let's see, we need to return this. So we're just setting up a bunch of different variables in order to compose the URL request. So by doing it this way, we can actually move everything here. So all the networking stuff that we need for the endpoints would actually be contained here, only in this sole file. So it'll be easier for other files to use. So we have base URL, and then we'll have method. Method is a HTTP method. It's gonna, all right, let's do switch self. And so for to-dos, it's gonna be a get. Return .get. Alright, so that's our method, and for our path, it's gonna be the strings that is appended from here. So in this case, it's gonna be to-do/1. So we'll just set this up. Var path, which is a string, and a string. Again, switch self. Case to-dos. Path is here, to-do/1. So that's our path for that case. Alright, and the next thing we're gonna need is the variable for encoding. It's gonna be parameter encoding. And so for here, switch self again. For the parameters encoding, you can do case. Actually, we're not gonna switch self. We're gonna switch method. So whatever method it is, like if it's a get or a post or a put, we can have different. Like if it's case get, we can return URL encoding the default or .http body. So it basically is like setting up, so in a case that the default is if you have a get HTTP method, it encodes the parameters as a query, and if you have a post method, it encodes it as like a HTTP body. So if you do a default, it will do it this way, and in our example, we're not going to really make any extra modifications, so all of our encoding will just be the default in this case. So we'll just do a default also to cover all the different methods that we have. If we look at the methods, they have all these methods here: get, put, patch, delete, a lot of different methods. So we'll just have a default there. And so for default, we're just gonna go URL encoding dot default. Actually, and we don't need this because this one will just cover it. But if you need any special encoding, we can modify that here. Alright, let's see. Next one we'll need is the parameters. Let's move this out of the way. Parameters. So for parameters, it's parameters. It's gonna return parameters object. Switch self. Case to do's. We don't have any parameters, so we'll return nil. Alright, what's going on? Okay. And then we have body, which is also parameters, but instead of they're basically the same except parameters. In this case, I plan to use it for it to be encoded in a query kind of manner, but body is going to be encoded in like a JSON kind of body dictionary that we can send over. So it's basically going to be the same for now, but later on when we have something that you need to send the body, then you can modify for the other cases, other endpoints, to send a specific body or a specific query for parameters. So we have that there, and just two more variables. So we'll have one called additional headers. It's going to be type HTTP headers. So this is in case you need to send specific headers for some endpoints. So we'll do self. So in this case, we only have one endpoint for now. So we'll do to-dos, and let's give it some default headers. We'll just have a header here. We'll just have a fake header called token for this example, and then we'll just call it some token as the value. So we'll send that as part of the header, or when we're done setting it up, it will send that as part of the header. And then last thing we'll have for this example is timeout. It's going to be of type time interval, and again switch self, in our case to do's. Actually, let's just do the default, because let's make them all the same time interval. So we'll do 20-second time interval. So that means if the API request hasn't completed in 20 seconds, it's gonna throw the timeout error. So this can be done on case by case. So if you have other cases, like if you want to take a little bit extra time, you can give it like 60 seconds. but default is 20 seconds, plenty of time to wait. So let's just make them all 20 for now for simplicity. So we've set that up, and all right, so next thing we're gonna do is we're gonna set up the an API router structure, which is gonna be an aggregate of this API router in order to make calls. So we're just gonna have a structure. We'll talk through it as we do it. So we have APIRouterStructer. It's gonna conform to URL request convertible. Let's see what this URL request convertible is. So it's an Alamofire protocol that is for adopting this so that it can be used to safely construct URL requests. So you need to conform to this so that it can make save URL requests. So we'll just go through it. It does not conform to this protocol because it has one function that we need to conform to in order to conform to this protocol called as URL request, which is basically gonna return your URL request. So if we click this here, we fix it, it will throw in the protocol in there for us that we need to conform to. All right, before doing that, let's have a variable called APIRouter. That's basically going to be an instance of this API router that we've set up, and based on that, it's gonna use this or use parts of this to construct the URL request. And all right, let's start constructing this function, the as URL request function. So we'll create a URL APIRouter, which is this function here, dot base URL dot as URL. Let's throw, so you can throw. So we'll mark that with try. So now we have URL. So now we need to make a URL request, var URL request. So we'll have a URL request object, and we'll just pass in the URL as the parameter. So URL request will do URL dot appending path component. So that'll go base URL appended by the path. So path component that we have is going to be APIRouter.path that we have. So the base URL is defined here, and the path is defined here. So by the time it's trying to construct this URL request, it's going to have this base URL and this path. Okay, so missing return function. All right, let's get rid of that error. So for now, we'll just do that. We'll have a few things later to add in here in between. So with all these different variables that we've created in this API router enumeration type, we can put those to use in this function in order to construct the URL request that we can return in order to make the API call. All right, so let's keep going. URL request, HTTP method. The HTTP method it will come from API router method dot raw value. All right, so it'll tell us if it's like get or post or put or whatever other HTTP method that you've defined for the variable. And then URL request, we'll do the timeout interval that we've set. Same kind of pattern, API router timeout. And then we'll do the header, URL request, headers. All right, so now we have headers. And so here we have this variable called additional headers. I mean, with this, I've thought of it in a way where you have some default headers and some additional headers. So let's say you want to have a case where the default headers, where all your API calls are going to have these headers. You can define them here and append the additional headers to the default headers. So that's the way that I was thinking about that. So let's just have a function called headers. So that one's gonna return the HTTP headers, which is like our default headers that we'll have. So we have a variable called headers dictionary. So in the headers dictionary, we're gonna, let's just say we have two. So we have a key accept, and we have application/JSON as the MIME type, and then so we'll have another one. For example, we'll have origin, and we'll have some origin as the value. So we'll have this dictionary here that's going to be part of the default headers that all of our calls are going to pass into the headers. So here we'll do if let additional headers. Those are the headers that we've defined in our API router enumeration. API router additional headers. Since it wasn't optional, we'll check to see if there's actually a value. If there is, we'll assign it to a variable called additional headers. And from here we can extract each of the additional headers and append it to the headers dictionary. So we'll do let additional headers dictionary equals additional headers. We'll do headers. Additional headers dot dictionary. Alright, and so we'll iterate through each of these objects. Additional headers dictionary, we'll do a for each. So for each, it has a key and value, which are both strings. So we'll do key and value, and then you just do headers dictionary, which is our initial dictionaries that we have, and then we'll assign the value to the key of the header. So it should look like this. There, header is key, and then at the end of it, we're just gonna return the headers dictionary, which is this. Let's see. Oh, here we'll do a comma here. Okay, cannot convert to return type headers. All right, so we'll just have to make a HTTP headers object and passing in this dictionary. So now that should give us the HTTP headers. So now we can make URL request.headers equals headers. All right, so that's just assigning the headers. It seems a lot for now, but it's setting up the headers. That's a one-time thing. So by the time you're setting up your other endpoints, everything would be easy, because this is like a one-time setup. So the API router structure is like a one-time setup, and your new endpoints that you have, you'll be just adding the cases to here, and then you'll be just adding the different variables and base URLs to your variable. So it's just tedious for the first time that we do it, and then after that it gets a lot easier to add values. So next thing we're gonna set up is actually we can also, I just want to show you that we can also set values in this way for the headers. So let's say we want to send another header, we can set value application JSON, and for HTTP header field, let's say we do content type. This is like, we can also add this here in the headers dictionary, or we can add these here and set them individually in this way. So again, okay, we'll just move away from the headers topic for now, and then we'll just I will do the body. We'll just move on to the body. If we have a body, API router dot body, which is an optional parameter. So if it falls into this if block, that means the body is not nil. So we're gonna do and then alright, do catch. We'd like to do catch first. So we're gonna try to get the data from the body that we have, which is the parameters. So do let data equals JSON serialization dot data. So it's gonna try to get the data, or to create a data from the parameters that we got with the JSON object. Our JSON object is gonna be body, and our options gonna be let's just do pretty printed. So we have data, we have pretty printed, URL request HTTP body. We'll assign data to that, so that's setting our body. And if it falls in the catch block, that means this try fail. So there's a try here. So if it fail, now we're just gonna print it out. Fail to generate JSON data. Alright. Okay, so similar thing for parameters. We're gonna check if they're if that parameters equals APIRouter.parameters to see if there's any parameters that we need. URL request. Let's try APIRouter.encoding.encode. Encode URL request. So encode URL requests with the parameters. Alright, so this is the thing that would add it to the query, to the query part. So print URL requests. Okay, so at the end of that, we're okay. We're gonna print URL request, so we can see our URL request that we've constructed. Alright, so that is our that's basically the whole setup for the API router and the APIRouterStructer. And alright, let's see how everything works. So for the next step is we're gonna set up connection settings, which is something it's gonna have a function that gives us a session so that we can use these to make the call. So we'll do a new file. We'll just call this one, do a Swift file. We'll call this one connection settings. Alright. Connection settings. We're gonna have foundation, and we're also gonna import Alamofire. Alright. And from there, we're gonna have a structure called connection settings. Okay. Then we're gonna extend this. What happened with my auto completion today? Extend. Okay. Oh, it's not extend. It's extension. Extension connection settings. So here, we're gonna have one function, only one function, called session manager. This one's basically gonna return us the session that we can use in order to make the API calls. So we'll just have some configurations, and then we'll just create a session out of those configurations. So let configuration equals URL session configuration. We just use the default configuration, and then we can configure those default configurations. There's a lot of properties that we can modify. So these are some of the properties. So we'll just modify request cache policy. So let's see, what are the values? reload ignoring local cache data. So that basically tells us that when you make the API request, the caching part of it, it's always gonna reload even when you have cache data. Because Alamofire, if you don't set that, or actually URL cache equals nil. So if you don't set that, it's gonna cache if it's seen a request made to a specific URL and endpoint, and it sees a specific like a return value, it's gonna cache that. So next time, it will just grab the response that it saw before from the specific base URL and path from the specific endpoint, and it's gonna return that to you. So if you want it to always reload, you do this. So I mean, there's a few parameters that we can set, but we just leave it at that because it's not important. We're not gonna really go too much into this. So we'll just create a session manager, and we'll have a session. And for the session, we're gonna it has a lot of stuff. We're not gonna pass everything. So we're just gonna have this configuration. We're gonna remove everything. Request starts immediately. We'll just do this false, and then I think that's it. So all right, we can go into here and see the definition. So it basically tells you or explains to you each of the different parameters and what it does. So starts request immediately is it determines whether this instance will automatically start all requests. True by default. If set to false, all requests created must have a .resume call in order for them to restart. So when we make our call, we're gonna need to call .resume in order to force the request to start. So right from here, we'll return the session manager, and that's it for this file. Let's see. Okay, so we return the session. And all right, the next thing we need to do is we're gonna need to create our we're actually gonna use the promises to as part of our networking call. So so promises are used to kind of like handle the mess that comes with asynchronous programming. So some examples are if you have to make an API call and you need to get the result back, and then you need to make a successive API call using the results that you just got back. There's like different patterns that are normally used, like for example notifications, delegates, callbacks, like things like that, and it makes the code like hard to read and hard to follow, and it's not as elegant. So when we have those things, the API calls can really get messy really fast. So which is why using promises is kind of nice. You're able to make successive calls using the values that you get back. You can map the values. You can wrap different objects into promises and return those, and you can keep chaining the calls in order to keep passing those values along. And it's also pretty good for error handling because you can like basically catch all the errors. Like when you want to make one call, not when you want to make one call, but when you want to make one service that needs a lot of calls in order to satisfy this service, you can chain a bunch of those calls, and if anything errors out, we can handle all the errors there, and the code's pretty easy to read. So that's why I kind of like using promises. So that's kind of like the reasons on why we should be using promises. So now let's just create the file that's gonna be our helper in order to use the PromiseKit in our API call. So we'll create a new file. We're gonna call this one Session Helpers. So for session helpers, we're gonna have import our Alamofire, and now since we'll be actually dealing with promises, we'll finally import PromiseKit. All right. So let's get started. So we need to have extension on session, which is session is an Alamofire object. So we'll have extension on all right, we have extension on session, and then we'll have a function called request. Request is gonna have the generic T, which is codable, which is encodable and decodable. But actually, all right, let's see. All right, so it's gonna take a parameter called URL convertible, and the object would be the APIRouterStructer. So, which we've defined that returns a URL request convertible. Let's just call this URL request convertible. Is it convertible or convertible? Convertible. All right, so we'll have that, and then our return type would be promise of type T, which is here. So T will be guaranteed to be codable, and we're going to return that in this function. So, right? Okay. So here we're going to return promise of type T. Do seal in. Okay, so this is where we start to make our request. We make our request. So we'll make our request. It's going to take our URL request convertible, and we'll do response. So we have different kind of response that we can get, but here we want response decodable, because we're assuming that we're gonna get a codable, which is like basically like a JSON, which is codable and decodable. So we'll do response decodable. Later I'll quickly show you, like, if you wanna get a response data instead of the response JSON, how to do that. But here we'll just leave it at that. And so in the response decodable, we're gonna get back an object that is a data response. Oops. Data response decodable. All right. So data response T and AF error. Okay. We'll just call this response. So we'll get this back. All right. And then we're gonna check that response is not nil. Guard response dot response is not nil, or else we're gonna reject it. So promise, you can either fulfill or reject. If it rejects, it basically just sends back like an error, and the actual caller side of it would go into the catch block, which is you handle the error how you want to handle it in your catch block. If the promise is rejected, and if it's fulfilled, it's gonna pass along the value. So here, if we get no response, if the response is nil, and we'll just send back some sort of error. So we'll just create a default error. For now, we'll just call it internal error. Enum internal error. We can have different kinds of error also, localized error. So we'll have a case called unexpected. Like, you can define other errors if you want, but to keep it simple, we'll just have internal error unexpected. So okay, if let error equals response dot error. So if the response dot error, all right, then we'll do seal dot reject error. Otherwise, Otherwise, we'll just do cu.reject internal error.unexpected. So otherwise, you just send back the unexpected error. Okay, so in this guard block, if it didn't reject, in the end, we're gonna know that our response.response is not nil. Alright, must not fall through. Okay, so we can do a return here. So now we'll do switch response.result. So result, it's gonna be either success or failure. So if it's success, we're gonna get back some value. Let's do something with that value. If it's success, we're just gonna fulfill. Our promise is fulfilled, and we're gonna send back the value. And then we're gonna have a failure case.failure. So if it fails, again, we're gonna do oops, I forgot the colon. cu.reject. We're gonna reject, and we're gonna pass back this error. Alright, and at the end, we're just gonna call .resume in order to start the request. Alright, so that was that's it. That's just the function to make the request. Now we're actually ready to make the call, but let me go over this this other function really quick. I'll just copy this and paste it over here to kind of talk a little bit about data, because this one is basically expecting the response decodable. Like if you're getting JSON back, you can decode it. But let's say you're just requesting some data that's not a JSON. Like you can do something like this. We're not going to use it in this example or this tutorial. So we'll do a request data, and so instead of promise of type T, it'll be promise of data. Let's do an optional. The data might not be there. So instead of promise, it will be promise data, and then in response, we won't need a type. We'll just call it response, and instead of response decodable, it will just be response. Okay, promise of type data. Yeah, so that's type is okay. Computer is a little slow. The error is taking a long time to go away. But anyways, if you want to make a request and you're expecting to get a data back instead of JSON, you can make the call in this way. And so these are the differences: the function name, the promise type, the response instead of response decodable, and that's basically the difference. Anyways, just quickly wanted to mention that. All right, now that we're that's set up, that's basically the meat of this tutorial. The rest is just kind of proving that it works. So all right, let's just get to setting up the storyboard. So we're gonna make this call. So click on main storyboard. All right, taking a while here. Okay, computer's really slowing down. Oh, yeah. Okay, here's our storyboard. We're going to add a label and a button. We'll do a label. We'll do a button. This is just to display the data that we'll be fetching. So we'll do a label and a button. Alright, let's just set this up. Okay, top space is safe area. Leading space is safe area. Alright, let's just center this. Whoops. we'll just horizontal container. Oh, what happened? Click this one. Click this guy. Horizontal, vertical, and container. Add 2 constraints. That label. Alright, let's add the back too. Oh man. One computer. It's really slowing down. Trailing space is safe area. Alright. Let me just modify this. Let me just do align space is safe area. We'll do 20 to safe area. We'll do 20. Alright. Let's just reframe this. Command option equals, I think. Yeah, command option equals. We'll do line. That's just to put the element back in its place. And then we'll do number of lines. We'll do 0. Okay. Alright. Guess that's good. Let's connect it up to our ViewController. We'll open up our ViewController here. Here's my element. Alright, so we have our label. Control. Click and drag into here. We'll just call this my label, and we'll have then we have a button. Oh no, that's not a button, that's a label. We'll scratch that. We'll click the button, control, click and drag. Alright. Computer's really slow. We have an action. We'll call this one button press. Alright. Okay. So here, let's start. Alright, let's start by create. Okay, let me just remove this because we don't need this one anymore. Just X this out. Okay. So we'll be looking at our button press function. So we'll just create another function just to put everything into here. So when button press, we'll just do handle button press. So once a button is pressed, we'll just call a function called handle button press, and we'll put all our code to make the API call here. I mean, this is not even an architecture. I just want to do this for simplicity, so we make all our calls and stuff from our view controllers. Normally, a lot of times in various patterns, you would make the calls in other places like MVVM or Viper or Model View Controller, stuff like that. You would probably put this in a different files, but for simplicity, I'll just make all the calls and all the setup here in the view controller. So just to kind of show you how it works, but the placement of the call will vary, or the setup will vary based upon your the architecture that you want to go for. But for simplicity, I'll just do everything here in this function, handle button press. So we're gonna create a APIRouterStructer. APIRouterStructer is gonna be APIRouterStructer, and it's going to take in an API router. So our API router only has one case, so pretty easy. We'll do to-dos, and so we're gonna call the next variable to-dos promise, It's gonna be of type promise. Oh, we need to import probably PromiseKit for the auto completion to work. Alright, so okay, there's my auto completion. Promise to do. Then we're gonna have our session. Oh, we need to create a session first, which is why we had our connection settings. So for this, we'll create a private variable, private lazy variable. So it will only be instantiated once. Session, and then so we create a session here. We'll just return connection settings dot session manager. So this one will the connection settings reminder has one static function called session manager that does the setup of a session and returns the session to you. So that's what we're calling here, and we're returning this to I guess session is a Alamofire type, so I guess let's import Alamofire also. Okay, so now this function connection settings.session manager returns to you the session. So we can use this session in order to make the calls that we're going to need to make. So we have sessions, sessions.request, request convertible, APIRouterStructer. Alright, so that's our to-do's promise. It basically tells us it's gonna be of type to do, but we don't have type to do yet. So go back to our browser, and it has this type, and then we'll create a model. So sometimes, let's see, we'll Google for let's see what we'll Google for. So what we're trying to do is we're trying to set up the model, but there's a quick way to do this. I usually just Google model generator. Let's call it Swift. JSON model generator Swift. Quick type. Okay, quick type. So click on there. Open quick type. And then so that's a welcome greeting instruction. So name, we'll just call it to do. Name, we'll call it to do, and then we'll paste our JSON that we're expecting in here. So it just creates a new model for us, which is really nice. So just copy this, and we'll create a new file. Let's just do a new group, because these will be models. So we'll create a new group here. We'll do a new file. Have a new JSON file, and we're just gonna call this to do. So I just copied and pasted over from the QuickType.io website. So now we have our to-dos object, which is a codable, which conforms to codable, which in our session helper, it basically tells us that the generic object that we're taking is going to be it's going to conform to codable. So everything lines up as expected. You can continue. So now we have a promise type to do here, so that when we make this call, we expect the return type to be of to do wrapped in a promise. So, and then we can start by saying firstly, which is like the first thing we're gonna do in a promise. We're just gonna do firstly to do's promise, and then after that we can do a then. So when we do firstly to do's promise, after the promise completes, it will either complete with the the success, which is like a fulfill or the reject. After it's done, it's gonna send back to the to-dos object. So now we have the to-dos object here, or to-do object. Just call it to-do, and then we can send back like we can send back another promise. Let's say we kind of forward this or something. We send another promise of type to do, and then let's say when we get the to do back, we populate our label that we have here called my label. So we'll have a we'll capture week self, and then here we'll to avoid memory leak, we do this. So we'll do strong self. Here I have auto completion set up. So I just have to type strong self, and then this will come. Alright, let me just briefly mention this because I'll be doing this a little bit. So I have something set up like a template, like where if I hit strong, it's gonna complete with strong self, and it's gonna give me a template set of code. So in order to do that, just quickly go over it. Here I have let me see. So I have here, like if I want to type in like if ABC, alright, it says I just want to complete this, right? I highlight this code, if ABC, go to editor, go to where do I go here, create code snippet. So once I go to create code snippet, I can say okay, example, alright, example if ABC. And then so language is Swift, platform is all, completion is if you start typing something, it will complete. So let's say I just do a completion ZZZZZ, done. Okay, so now I have this template called if ABC. So once I go here, and if I start typing ZZZ example, and then if I hit it, the highlighted block will show up ZZZ. So anyways, that was just a quick thing that we have. Let me just remove that from my template. So plus example, just delete this template, don't need that. I was just showing you guys how to set that up. Alright, so we'll, instead of return, since this one promises a to do, instead of return we'll have to throw something. And since we have our error that we created from before, internal error unexpected, we'll just throw that. Otherwise we have self, and then we're just gonna set the label self dot my label dot text to do dot title. We have things that we can display. These are the objects that we can display, or the keys. So the value will just display the value of the title here. So to do dot title, we'll just display that for now, and then we'll just do a dot just do a dot catch. Okay, so in catch we're just gonna catch the error. So when there's an error, let's say we're just gonna print there was an error. Or if you wanna display something to the user, you can do the same thing. Let me just copy this over. You can do self.myLabel.text. Actually in here we don't throw anymore, we're already in the catch block, so we're just gonna return myLabel.text equals there was an error. Alright, and then after the catch we're gonna do finally we're just gonna print finally done. Finally is like it will the finally block will execute no matter whether your promise succeeds or fail. So firstly, it will always execute the first, and then catch will execute when there's an error in any of your thens. Although now there's only one then. Oh, here, promise to do, we didn't return it, so we'll just return promise to do, promise to do dot value to do in this case. All right, so let's just run this, and just to do a quick sanity check, making sure that everything is still working before we continue. So we'll just pick iPhone 12 Pro Max, run this, give it some time to build. It loaded. All right. So we're gonna hit a button, hopefully. All right. Hey, it worked the first time. When did that ever happen? Okay. Okay, so it printed finally done, which is good. It printed our URL request, which is good. So from here, we've asked it to print our URL request, which it did. And in here, it printed out the finally block, which is good. Networking template. All right, we're just gonna ignore that. We're just gonna assume it's a simulator error. Okay, so that was all right. So let's do something else to kind of show why promise is good. It's a good way. So here you can do a then, and then you can extend it with another then. So now you have a body. Not a body, sorry. You have another then block which you can extend. So if you want to do something else, like you want to make another call. Actually, all right. To make another call, let's modify. How should we do this? Alright, let me modify the path of the API router first to kind of see that it's actually work. Alright, so let's say to-dos/2. We'll run this again. This time it should be a little bit faster because it built the first time. So now it will get the to-dos 2. So now our title is Quiz us num facile et officia qui. So now that's our expected value. So now that it launched, or I hope it launched. Did it launch? Alright, let me press this button. Makes the call. Seduce 2. Wait a little bit for the response. So now that's our title, which is the same. So in order to kind of show this, maybe we'll modify the to-dos a little bit. So instead of to-dos being fixed, because we have this path here, we're going to modify it so that it kind of so this part is dynamic and not fixed directly into the path. So in order to do that, we can have parameters in the to-dos case. We'll just call this number, which is an int. So we're gonna modify this to be whatever this number is. So we have that, and in our all the parameters will stay the same except the path. So now the path, we're gonna where's our path? Okay, so here's the path. So instead of to-dos, we'll just do to-dos, and it's gonna take a number, or not take a number, it's gonna have a number. So here we're gonna return to-do/number, not number, here, this number, so that we can use this number as part of the path. So now the value coming in is gonna have to take a number. So we need to modify the ViewController this promise. So instead of dot to do's, now it throws an error because it needs another integer to go with it. So now we'll just do the call here too. Actually, a better way might be to set up a text field, and then we can type in any number, and then it will make a call, and then from there we can make the call. Alright, to do's 2. Alright, so it gave me the same result, which is good. So let's go with the plan. Let's make a text field, and then we'll just have it be dynamic based on the text field. And then we'll use the promise in order to just put the text field here. Text field. Oh, this is pretty bad. Alright, top space is safe area. Control click drag. Safe area. Okay. Trailing space is safe area. Alright, vertical spacing. Okay. Alright, let's see if we can make this one maybe a little bit bigger. Trailing space, we'll do 50. Okay. Alright, it looks pretty bad. It doesn't matter for this case. Here we'll have a placeholder called number. Then we need to hook this up to our ViewController again. Get our ViewController to load. Okay, so we have our text field that we're gonna use, and we're gonna use the number in this text field in order to make the API request. We're just gonna call this one text field. Alright. Alright. So now let's close this again. We don't need the storyboard anymore. Sorry. All my clicks are delayed, so after I click, it waits another like 3 seconds in order to react. Okay. So here, since we've added this, we can instead of just a flat number 2, we'll just do let number equals text field dot text. Okay. If let number string, or let's do guard let instead. Guard let number string. So now number string, now we have something. So let number equals, let me do this, int number string, else we're just gonna return. Alright, so let me make sure number is an error type. Why? That's a way to cast this one. Number is of error type. Why is this number of error type? Immutable value number was never used. Let me just try to pass it here to see if we can pass it here. Is this the way that we cast a string to a number? Computer might just be slow. Maybe it'll work. Maybe that is how you cast a string to a number. Alright, build succeeded. So now we have a number, and we're gonna type a number in a text field, and our request is gonna be modified to that, and then we'll show you how to maybe use PromiseKit in a way that takes advantage of like PromiseKit. All right, so do number 1. So it makes this request and it returns that. We'll do number 2, makes the other request, number 3, number 4. Okay, so it seems to be working as expected. So in PromiseKit, let's say we want to use that value in order to do something else. So what can we do? Can we do with this value? All right, let's have another then block, because then that's basically what we need to do. So we have a to-do object that is passed back from the previous block. So let's do another weak self, and then we'll throw an error in case we're not able to get self. So let's display my label.text equals let's get a previous here. We'll copy this over. This is the previous text plus actually let's make another call. How about let's make another call successively? I think that'll take advantage of it. So we'll have another API structure and to-do's promise right into this then. So we'll have our let to-do's promise to-do's promise next, and next instead of this, so APIRouterStructer to-do's number. So instead of this number, it will be so we get, what do we have here? We have the ID is 2. So we'll do to-do dot, oh man, I wish we have okay, so let's return promise void for now, just to kind of get rid of the error so that my completion would work normally. To do has an ID. All right, we'll use something with ID. So we'll get the next ID. To do equal to do's ID plus 1. Let next ID equals to do the ID plus 1. So now instead of to do's number with number, we'll do to do next ID. All right. So and now to do's promise next. To do's promise next will make a request and it will use this one, this structure. What's the error? Explicit use of self. Okay. So we have self here, self session request APIRouterStructer, and it will return let's return this to do's promise next. So instead of promise void, it will return to do. So it will make another, once it makes a call, I mean once it succeeds with the value, then it will go onto this then block, which returns the to do object from this call here. So this one we'll call it to do next, and then we'll return promise void, so which will return nothing, again with the weak self. Okay, and then so here we're gonna modify our label to display the, instead of to do's title, it will display the previous title also. So that self.mylabel.text, which is the previous text, plus the new to do's title, to do's next.title. All right, so we'll see how that works. Okay. Oops. I saw a brief error pop up. Value of optional type string must be unwrapped. Okay, let's just force unwrap it fast access. We know it's there, but we probably need to put it in another in the guard statement to be safe. Otherwise it might crash if the value is actually not there. But we know it's there, and for convenience and quickness we just do a force unwrap. Alright, so if we hit this, nothing happens because it didn't succeed from this guard. So let's put in number 2. So it makes this call, and it makes this call. Actually, let's put it on a new line. It's hard to tell. N. All right. Okay, so now we have this. We'll make a call to number 2 or number 1. So it makes a call to do /1 and then to do /2, because here's the +1, and to do -1 title is that, to do /2 title is that. So here we're basically showing that the promise, it used the value from the previous value, and it added a 1 to it, and it makes another call, and then we can keep chaining if we want. Like if we want to do it again, we can do we can just do that right in here. So now we've updated the title. Let's say we want to do this one more time. Okay, this is the last one, but it's the same thing. I think you get the point. So here we've updated the text. We'll have another one called next ID, to do.id. Let's say this one is +5, so it's gonna get the 5th ID from the to do that was passed in, or to do next. Get next ID, API router, to do next ID, to do's promise next, return. We'll return to do promise next. Alright. So there, and then we can have another then block, and then from there we basically copy over maybe this part. So then we return. So here instead of void, since we're returning to do's now, so we'll just return a promise to do. And okay, this would be the last one. The code is looking kind of long. I'm doing something similar. MyLabel.text is to do next. Alright, then we return promise. Okay. I guess putting a number next to it would be nice. Alright. Okay, so I guess let's put a number next to it so we can kind of keep track of what calls these are. So here, mylabel.text, instead of just to do.title, we'll also include to do.id, which is an int. Hopefully, alright, let's do this. Leave a space. Okay, so we'll have a number to go along with each of the titles that we get. So here we'll put it there, and then we'll put it here. So here's actually to do next.id. Alright, we have that there, and then we'll have that here one more time. Okay, let's run it. Hopefully it works out as imagined. Okay. So as it's running, let's just go over it. What we did. So firstly, we have a to-do's promise, which makes a call to the to-do's endpoint with the number that we pass in the text, and then from that we update our label to to-do's number plus the to-do's title, and we return the to-do's value unmodified. We could have modified it, but we return the to-do's value onto the next block, and from there this to-do is being given here to this then block. So we grab the to-do's ID and we increment it by 1, and then that's the next ID that we get, and then we create another API router structure using that next ID that we've generated to make another call, and then from there we get the to-do's next object back. We update the label so that it shows the previous value plus the new to-do's value, and for this one we increment the to-do's by 5, and we make another API call using the value that was in the to-do's ID that was incremented by 5, and then we pass that on, and so on. Like if we have another endpoint, we can do something else in, like we can also make another call by modifying this API router structure, and when we get the to-do's next value back again, we display the previous text plus the new text that we get back. And this is basically just error handling. If there's an error, it will just show the my label text, and then it will just print finally done. So if I put 1 in here, according to this code, it should make 3 API calls. 1 for to-do/1, and 1 for to-do/2, and 1 for to-do/7, which is 1 plus 5. Alright, so let's hope that that's what it's doing. So to-do/1, to-do/2, and to-do/7 as expected. So 1, 2, and 7. So we can verify this. In the Postman. Alright, so here's to-do's 1. We make this call and we get this Delectus aut autumn, and then 2 we'll get back quis ut nam facilis et officia qui. I'm making this up, by the way. The pronunciation hopefully is correct. And then 7 is illo expedita consequitur qui in. All right, so those are all our calls, and it looks like it's working so far. This tutorial is running pretty long. All right, let's just add one more example in the API router, and then I think that'll end the tutorials. Alright, let's just do one and that'll end the tutorial. Just to show you how easy it is to add an endpoint. So that was kind of like the initial setup, and then later you're like, oh, let me have another endpoint I want to integrate into my project. You know, like everything's already set up here. So let's go back to here and then look for a post, because we have done the get already. So post, we have a /post here. Actually, you can use this, or let's do a post. Let's see, get post, or do we get post? User ID, title, and body. Alright, user ID, title, and body. So I think for posts you need like user ID, title, and body. Maybe just title and body. Let me see this again. So those are get posts here. Get posts /1. User ID. Okay, so we just copy this into our QuickType, instead of to do, we'll just call this post. All right, the name's confusing. We're gonna do a post method, and the actual name of the object is post. They're unrelated. Post is kind of like, you know, like a comment or some kind of news post or something. So that's that kind of post, and different than an HTTP post method. So just wanted to throw that out there. A little bit confusing, but all right. New file. I'll just call this one post.swift. So it'll be a model also. Alright, so in post, our post will have user ID, title, body, and ID, because that's what the post has. So I guess we'll send that in. So let's try to make a call with the postman just to kind of see. So this one would be a post. The call would be post to sorry, here. Let's go back. We have a post here, slash post. Oh, the slash, double slash, slash post. So we're gonna modify the body. Do a raw type would be not JavaScript, JSON. Oh, need to copy. That's to do. Sorry. Here's the post body. Alright, let's copy this. Paste it here. Let's send and see what we get back. Alright. So I guess the ID is the thing that is provided by the. So it looks like it's when I make this post call, it just echoes back the thing that I've sent, except the ID, which is always 101. So I guess the ID is not needed to make the call. So let's see. Okay, so the ID is being generated by the backend. All right, so we'll just use this as a model. So our model that we're sending back to the server for this post is a user ID, title, and body. So for this example, I'll just make it here. Post body. So we'll just create a structure called post model, which is gonna have so I've copied it. So it has title, user, and body. So we'll do let title, which is a string, let body, which is a string, let user ID, which is an integer. Okay. So that's what we need to send to the server in order to get this response. So the response is a user ID, title, body, and ID, which we've pasted into QuickType, and it generated this model for us. So this is the post model that we'll be sending. All right. So, all right, let's modify our API router, and in order to add this call. So now we have another endpoint we want to integrate. In case to do's, let's do case. It was called post. Let's see, case post. So in post, we're gonna take our post model, right? Does it have a post model? Okay, so this is the post model. That's good. Let's go back to API router. Cannot find type post model. Switch must be exhaustive. Well, yeah, man, I wish the error would come a little bit later. Now the red is kind of throwing me off. Okay, let me make sure it doesn't error out. Post model. Okay, so let's just continue. So for the base URL, it's gonna be the same base URL because it's not a different base URL. So we'll do that. So for the to-dos and posts, cannot find type post model in scope again. All right, but why? Let me check type post. Why can't you find post model in scope? Wait a little bit. Post model, title, body user ID. I'm just gonna assume the error will go away after a little bit of typing through it. So case.post. So if it's a post, the HTTP method is a post. And if it's, and this is the path, so if it's post, the path would be post. We're not going to use this here. Yeah, this is really bugging me. Alright, let's just have it as in for now, and then we'll just come back and modify this later. Okay. So that the error kind of goes away for now. Encoding, we'll leave that as is. In parameters, we don't have any parameters, but we do have body, so so dot post is also nil, and so for a body post we do have body, and in the body we're gonna need to create a body for the post model. So let return so for the body, let's go to make let's go to our post body, and let's make a body where it's suitable to make an API call. So we do extension post model, and extension post model, it's going to have a function called body for API requests, and it's going to be of type, it's going to be a dictionary string of type n. Okay, so we're going to have a body which is the return type, a dictionary of string value any. So we're going to initiate it with an empty dictionary, and then we're going to return body. So we need to convert this into a dictionary in order to send to the backend, to the data. So here we see that it needs to send user ID, title, and body. So we need to modify our body. The key is the key for user ID. Here, just pull this up so we can see. Actually, this doesn't really. Key is user ID. It's gonna be self.userid. Body for title, it's going to be self.title. Body for body is self.body. Okay, so we could have actually just used title and user ID here, But body, since this is body and this is also body, we have to use self. Guess we can rename it something else. Body for API. And then so here, let's just modify this. Okay, that was a shortcut. Control Command E. Click on here, Control Command E, so then we can modify everything at once. Body for API. So now everything is here, then we don't need self anymore. We need the implicit self, user ID, title, and body. So now we have generated body for API requests. Let's go back to the router, and then we need to make the body for API request. But now, post model, I think it thinks it's an int, but we need it to be the type of post model. So let's go back and hope that it works this time. Post, how come it doesn't find it? What's going on? Structure, post model. Let's move it directly into that file for now. Maybe it would help. Again, not something that we've done, but okay. Okay, so now we have a post model. Let's see if that actually helps anything. That helps, but I don't know why it didn't detect it. Let's move it. Maybe we need to just create a new file for it. Let's see. New file. We just call this post model. Okay. Let's see if that helps anything. Again? Why? That's odd. I think it's just a temporary compiler or ID issue. Let's just move it here for now, and then we'll move it to its file later where it looks nice. Okay, let me copy this or cut this, and then we'll paste it into here for now, just for the sake of auto completion, and then we'll move it back later. Post model. Okay. Alright, so now it detects the post model. Okay, where are we? We're at the body. At the body, okay. So we have post model, and we just created a function called body for API request. Here in our, oh, not there, sorry, we moved it here. Here is the extension body for API request in order to generate this dictionary. So now we have that post model. The warning didn't go away even though we've used this, but anyways, to-dos. So case.post, let's say we don't have any, so we just return nil. Timeout, we just return 20. Okay, so I think that's basically it. We'll go back to our ViewController. Alright, let me go back to APIRouter to explain that a little bit, because I was jumping all over the place. I was getting thrown off by this post model object not completing. So for the APIRouter, we have a new endpoint called post. And for the post, we basically assign all the different values to each of the variables that we have in order to tell you how to generate the URL request. So base URL is the same here, JSON placeholder.typebycode.com. The method is post as opposed to get. The path is just post because this is the path here. Encoding is the same, the default. There's no parameters. And for the body, we have the dictionary that we've generated. There's no additional headers, and there's the timeout is still 20. So that's it. Just setting up the post, and we'll have we'll create another function. This one is to handle how to use the new call that we get, function handle button press 1. All right, so this is gonna handle it in a different way. So similar to handle button press, which is basically a successive API calls, handle button 1 is maybe we're just gonna do a post and a get to kind of demonstrate that we can use both the post and the get call in the in like the same call using Alamofire and Promise. So we'll just kind of do the same here, maybe to start off with. We'll have a number, we'll get a number, and then all right, I guess let's start off with the post. Can we start off with the post? All right, let's start off with the post. So post model, we need to generate a new post model. Post model takes a title, hello, title, body. This is body. User ID is call it 20. Let post model is that, and then so we'll send in post model. So let's do post promise of type post, because post we've already created our codable body from before. So that session request APIRouterStructer. Okay, so in theory that's actually it. That's not it. Just need to make our call, our firstly a post model, then do something with the model that we get. Oh, firstly post model, let's see, global function firstly requires that post model conforms to Venable. Let's see, promise post APIRouterStructer. Hang on, I'm going to see the post, which is codable. All right, let's handle the catcher now. Catch and finally, we'll just handle it the same way. Global function firstly execute by the post model conforms to Venable. Alright, let's run it and see that it still throws an error. Alright, let's try to figure out what's going on. Oh, because I'm trying to send back post model, which is actually of type post model, I want to return back post promise. Sorry guys. Post promise. Alright, let's do something after we get the then we get a post back after we do the post promise. Just call it post. Again, caption weak self, strong self. Instead of return, we're gonna throw the internal error unexpected as we specified, and then we're going to update our label self dot, where's my label, throw internal oh man, return promise void. Alright, okay, now it should autocomplete. My label dot text equals post dot, let's display again user ID user ID is post.user ID plus post.body. Okay, I think that should be okay. All right, so that's it. That's our call. Let's run it. I guess we didn't use this yet. We can use it in the next then. I'll show you how to use the next then, and then it would be it would kind of be showing how to make different calls with the promises, and this one is with the post. All right. Oh, we didn't modify it to call handle button press 1 yet. So here, instead of handle button press, we'll call handle button press 1. Is that what it's called? No, it's called handle button press. Oh, there's misspelled something here. Just copy and paste handle button press 1. So it'll call this function instead of this function. All right, let's make this call button anything. Nothing. Oh, because of this guard. All right, let's just put in a number 1. The number doesn't matter though in this case, because there's a guard statement here that kind of like made the function return because we didn't have the number in the text field. Here we go. User 20. Okay. Yeah, because that's what we put here, user 20, and this is body. So when we made the post request with passing in this model, hello title, this is body user 20. So we're getting back this user 20 and this is body, and we can also show that we're gonna get back the ID, which is always 101 as we saw. So let's display the user ID also. Not user ID, sorry, just ID. ID, which is post.id. Alright, we'll run this again. Some random number. Okay, so ID is 101, user is 20, and this is body. That's good. So that's as expected. And then we'll do another then here just to kind of show the chaining, and then this would be the last thing that we do. So promise voice, so we didn't get anything back. So I guess we can actually send back promise post. Send back promise post value is going to be the post that we get unmodified. I mean, in theory we could have not updated, but create another post object and send that back to the following block. So yeah, we get a post back. Then it returns a promise void return promise. Okay. the error here? Do we have another error? Okay, no error. Computer is slowing down extremely. Okay, so let's just make a previous call that we had. So we'll do we'll create an API router structure, and we'll do API router structure. No. And the router now will be to-dos, and the number will just be the number that we gather from the text field. And then we'll make the call similar to here. Let's just see the call. The to-dos promise. Just copy and paste this over. Okay. That to-do, so we have a to-dos promise using the API router structure, and then we just return to-dos promise. So now we're getting a post, but we're gonna return the to-do promise to do. Okay. So then we get the to-do back. Is alright, week self to do return. I had to do this first, otherwise it seems like the auto completion is just thrown out of whack. So I do this. Hopefully everything is okay, and then we'll update the label one more time. Let's copy this. self.mylabel.text equals the previous self.mylabel.text plus, let's go to a new line, plus to do dot what did we do previously? What did we display previously? We display the to-do's ID and to-do's title. Alright, we'll just do the exact same thing. Copy that over. Alright, so instead of to-do's next, it's to do. Alright, so now my label is going to be filled up with my label.text, a new line, the to do ID, and to do title. So now we've alright, so let's make a call and kind of see that that works as expected. Alright, step number 3, number E, number 3 button. So it makes a call to post. It's an error. Okay, well, hey, our catch block got activated, but let's see what happened. There was an error. Error request API router structure. Oh, it tries to Okay, it tries to use this API router structure instead of this. Is the name different? Oh, TUER and TURE. So it tries to make another call. Well, hey, at least it shows that it tries to make another post call and it was expecting a to-do. Okay, so this is uninverted, but kind of shows you how the catch block handles that, how it handles an error. So now it prints there was an error, and it updated the label to show you there was an error, and it finally done. Unintended, but kind of glad that that showed up. So let's just call this API structure. So we fix the spelling. So now this API structure, or this API structure, should now be referring to this API structure. So now the call should actually succeed. Alright, so call it number 5, makes a call to post, got the post body back, display that, and then for the fifth to do item, it returns this one. So that's basically the end of the tutorial. Basically showed how to create the API, to set up the API router with the API router structure combo. Also showed how to let's see, how to create the session helper to make the request that kind of returns the promise, and also showed how to actually use the structure in conjunction with PromiseKit in order to make the call and then keep chaining the calls into successive calls so that the results can be used onto the next block. And you can see that the code is actually easy to read because it's all like lined up just here without jumping all over the place with like either delegates or callbacks, notifications, like things like that. So, and you can chain many times, and errors is handled by the catch block. And if it's specific error that is thrown from somewhere else, like then it would be shown here. Or so because here we've hard coded there was an error, but if you want to actually display the error, you can just do error localized description or something like that, so that you can display the dynamic error instead of a static there was an error message. So that's the end of this tutorial. So that was the end of that tutorial. I didn't expect it to go that long, but at least we went over some pretty good information. We went over how to set up a networking layer using the Alamofire and PromiseKit and creating the API router. It took a little bit long because of the initial setup, but if you have more endpoints to add, then it actually cuts the time down a lot, because as you saw, you just have to add a different case and add the different variables or for each of the endpoints that you need. So the initial setup is long, but if you have more endpoints to add to that, and it's actually pretty fast and pretty easy to use. And with promises, you can chain calls and use the results from the previous blocks and to be used onto the next block. So that kind of solves the mess with the asynchronous calls. So there's no delegates, no notifications or callback. It's all just contained in the function. So all the calls is contained in one place. So makes the code easy to read, and there was no like right word in drift kind of thing where it's all the code is pretty aligned and easy to read. So yeah, the tutorial was kind of long, so I'll post the link up on GitHub for the project that we went over. So yeah, I'll share the description. I'll share the link in the description. And that's it for today. Thanks for watching, guys. Bye.